well, we're looking at cross sections. Now, a cross section is when we've taken a solid, we've taken a three-dimensional figure, we are intersecting it with a plane. That's what a cross section is. So we can see some examples of some cross sections over here where we took a cylinder and we cut it through with a plane and we made a circle. Well, we could also cut through the top like this. We could have the cross section be vertical, and this is actually creating a rectangle out of our cylinder. So cross sections. It says describe and draw the cross section created by each plane. We had a plane intersecting a cone. We can see that this is a circle. That cross section is a circle. Here, the plane is intersecting our cube or some kind of rectangular prism at a diagonal, creating three vertices there. It's creating a cross section as a triangle. Here it says if the plane shown is perpendicular to the altitude of the cylinder, what is the perimeter of the cross section? Well, if it's perpendicular to our altitude, that means it is forming a nice perfect circle for us right there. We want to know the perimeter of this cross section, aka the perimeter of our circle, which is going to be the circumference. Well, the circumference is just diameter times pi. If the radius is 12, that means the circumference is 24 pi inches. This is not needed information at all. Here it says if the altitude of our cylinder lies in the plane shown, the altitude of our cylinder lies in this plane, okay? What is the perimeter of this cross section of our cylinder? Well, this cross section would be a rectangle. We know that'd be a rectangle. It's forming right angles. It's intersecting the altitude of our cylinder. If it's intersecting the altitude forms right angles and so forth. Hence, this must be a rectangle here. So, if the radius is 12, well, the radius is still going to be 12 right here. It's still going to be 12 right here, meaning that this rectangle is 24 by 25. Yeah. So 25 plus 25 plus 24 plus 24. This has a perimeter of 98 inches when we add those up. Great. Here it says find the area of our cross section of a square pyramid. Pyramid's 15 inches tall, the base is 6 inches wide, the cross section is perpendicular to the base of the pyramid and passes through the vertex. So that means this triangle that is formed right here, because that's what we have done, is we have formed a triangle in this cross section. This triangle, where the base is 6 inches wide, that means the base of our triangle is still going to be 6 inches wide. The height of the pyramid is 15 inches, so the height of our triangle is 15 inches. Well, if we find the area of our cross section, which is the area of this base, the area of our cross section is the area of this triangle, which is 1/2 base times height. Half of 6 is 3 times 15 gives us 45 square inches is the area of this cross section. Now, hopefully cross sections make some sense to us. This brings us to something that is pretty important. We've mentioned throughout all these lessons where we've dealt with volume and surface area, all that kind of stuff, we've mentioned Cavalier's principle. It says if two solids lying between parallel planes of equal heights and all cross sections at equal distances from their bases have equal areas, the solids have equal volumes. What we're saying here is if we have two cones, two cylinders, two prisms, two pyramids that have the same base and height, we find them the same way, whether they're right or oblique. Cone 1 and cone 2 are going to have the same volume because they have the same radius and the same height. Take a look here. There's a stack of CDs on a desk. You may not know what a CD is, but it's kind of like a Blu-ray that plays music. Okay? So if you need to imagine those as Blu-rays, you can. There's a stack of Blu-rays on a desk. The stack is bumped and makes a 70-degree angle with the table. Now, if the stack of CDs is standing straight up, or if the stack of CDs is leaning over to the side, it's still the same amount of CDs. It's still taking up the same amount of space, truly the same amount of space on your table, on your, in your room. It's still taking up the same amount of space. What is the volume of the stack? Well, it doesn't matter if it's leaning over at this 70-degree angle. Ignore that. We know that the CDs have a diameter of 4.75, a height of 8 inches. So the volume of our cylinder, that's what this is, even though it's leaning over, is area of base times the height. The area of our base is going to be pi r squared. And because the diameter is 4.75, I'm going to divide that by 2. 2.375 squared, which is our radius, times our height, which is 8. And we plug all this in. 2.375, we're going to square that, multiply that times 8. As an exact answer, it's 45.125 pi cubic inches. But if I round to the nearest hundredth, it's about 141.76 cubic inches. So it's not very specific in this problem here. This is the same volume as if the stack is standing straight up. We know it's not really affected by that Cavalier's principle.